Leca is a friction material, and the friction angle is kind of similar to what you have in crushed rock or coarse sand. So if you go to compare Leca and the frictional properties with a conventional material, that is where you are operating. There is one difference, of course, because Leca is a lightweight material. So the point is that it has a stiff core with pores, which means that if you are applying too high contact stress, then you may exhibit crushing. But then you are at a stress level which is not a conventional material in a conventional structure. So basically, if you consider it as a frictional material, you should think about it in a similar way as we do with a conventional crushed rock or sand. And if you're going to build a railway structure, you can use this as a lightweight fill, typically, for example, soft topsoil to avoid differential settlement. And then you have to have a superstructure above because that is to avoid the contact stresses that you have from the loading on the railway. But once you have established the Leca fill and you have established this superstructure, it's not a problem to build a railway structure on top of that one. And it has also some other, like we discussed previously, that it has lightweight, so you reduce the possibility for settlement, you reduce possible stability problems with the failure under the embankment, but it also has the possibility in the frost insulation for drainage, and also it can act as a way of reducing vibrations, because you can break the wave with using lightweight material.
Away from the high-speed trains.
For example, a high-speed train, we know that some high-speed trains in particular soil conditions, they can have vibrations. And using Leca can reduce the risk of having this type.
Yes.